Okay, back with problem 82. Looks like we're not going to need a calculator for this one either. It's looking for which statement is true. With these problems, you want to look to see are they asking which statement is true with 4 false statements, or are they asking for which statement is false with 4 true statements? So this time they're asking for the one true statement, meaning 4 of these are going to be false. And they give us a statement here. F is a continuous function, meaning no holes, no jumps, on the closed interval a to b. So I've got a point A, I've got another point B, and I know that I am connecting these points without a break. Now the interesting thing to think about here is, well, how could this vary? I drew something very simple, but what if point B was up here? And what if this dipped down all the way down there? Or what if it went up like this? So there's a lot of different options that can happen. So you really want to look to see these type of situations. So let's see. There's a number c in the open interval a to b such that f of c is equal to 0. Well, this isn't necessarily true. It could be true. We could cross through, if we're looking at graphing this, the value of the function being 0, being a continuous like that. But it doesn't have to be true. Our function could be completely up here. So it says must be true here, so A doesn't have to be true. Let's look at B. There's a number c in the open interval a to b such that f of A is less than f of c is less than f of b. Well, that could be true. F of A could be down here. F of c could be down here. And f of b could be down here, and that could be true. But what about if A was up here, B was down here, C was down here, B was down here? Well, then A is bigger than all of them, so B doesn't have to be true. Now let's look at C. There's a number C in the closed interval a to b such that f of c is greater or equal to f of x for all of these values. Here's the key thing. The fact that it is a closed interval, even if the value is less than, so even if we have, let me erase some of this stuff. Even if we have A right there and B right there, and the values are beneath the function, so it's not that it's really above the values. Okay, at the endpoints, they're at least equal, because again, it's a closed interval. So C can be any point on this function. It can be here, it can be here, it can be here, it can be here. So even though they're less than, the values of C are less than the value of the function, at this point, at some point, there's a number C, there's a number value, where it is at least equal to it. Maybe it's above it. Okay, in this case that I drew, it's not, but it's at least equal to those points. So C has to be true. This is sort of a confusing problem, but drawing it out helped for me, and a few students have already asked me questions about this, and we drew out the problems. Let's just go over the other answer choices since we're here. There's a number C in the open interval a to b such that f prime equals 0. That is Rolle's theorem, and it's just not necessarily the case. Our function could be a straight line like that, and there's no point where the slope is 0. Rolle's theorem says that there's 2 points that are the same. So if I have that A of B, if A is here, and I have another point B that's the exact same y value, okay, let's say it's 3, well then at some point there does have to be a slope that is equal to 0 in between. That's Rolle's theorem. But Rolle's theorem is not the case, does not apply here because we don't have 2 equal points necessarily. So D is false. There's a number C, for E it says there's a number C in the open interval a to b such that f prime of C has to be equal to these. Closed let's see, why would mean value theorem not work? Mean value theorem not here because of the open interval. So that's where that comes from. So that's not necessarily true either. Okay, a little confusing, but hopefully you can at least identify why C is correct. All right, we'll be back for problem 83.